All right, okay. I'll let people kind of give some feedback on this whole bootcamp experience in the chat, whilst I invite our today's speaker up to the stage. Today we have Andrej here from Chainlink Labs, and he's going to be giving a session on functions.
Hi, Astrid. Hi, everyone.
Yay. All right, are we good to go from your end?
Yep, all good.
Okay, I'll let you start presenting, Ben.
Perfect. I'm going to start with sharing my screen, guys. Okay, slideshow. Perfect. You should be able to see the title, Connecting Smart Contracts to the Real World. Okay, so as Astrid said, my name is Andrej. I'm one of the developer advocates for Chainlink Protocol at Chainlink Labs. You can see here listed my Twitter handle and my Lens handle. And as being said, the topic for today's workshop is actually Chainlink Functions. So Chainlink Functions is something new that we launched during ETH Denver. The project is still in beta, so you will need to in order to try it on a testnet/mainnet, you will need to go through a whitelisting process on a website, which is just filling a simple type form. But if you want to try it locally and simulate what the end result will look like on testnet/mainnet, you can do it. You can do it just without any restrictions, which is what we're going to do today, just to speed us up. But before we start, let's first quickly go through what the Chainlink protocol is. I assume you already know, because if you attended the previous Chainlink workshops, but let's do like a really quick recap. So first, to understand Chainlink, we need to understand what's the purpose of smart contracts. And smart contracts are basically digital agreements which solve the problem of trust. So we know that with smart contracts, we have two things that we're absolutely sure about it. They are immutable and they are public. That means that, like 24/7, no one can change the rules of the game, so you don't need to trust anyone, rather the logic in the code itself, which is completely different from the situation we currently have in the mainstream, where we are basically relying on a trust with traditional agreements. So you're either trust to a brand or like a logo or I don't know, like some paper guarantees, whatever. With smart contracts, you don't need to trust anyone because they rely on cryptography and blockchain as underlying technologies. Yeah, but smart contracts are not perfect. They're not ideal. There are several limitations with smart contracts, and the most obvious one is that they can access the limited set of data. So if you deploy a smart contract to a certain blockchain, it can only access some basic info from within, like I don't know, like the latest block number or the balance of some other address if it's present on that blockchain, etc., etc. So smart contract can't know like anything in the outside world. So imagine like Ethereum blockchain smart contracts on Ethereum blockchain doesn't know the price of Ether, for example. Or if you have like some L2 on top of it, smart contracts cannot natively communicate with other smart contracts on other blockchain, etc., etc. So there are like several limitations, and we can all put them under one umbrella. This is like a smart contract connectivity problem. So another, not say like a problem, but a feature of smart contracts is that they're like deterministic. So the problem is then with like creating a random values, but I'm not going to talk about VRF today, so we can easily just skip this slide. But yeah, so when it comes to smart contract connectivity problem, and what Chainlink offers is basically access to off-chain data and computation. Off-chain data meaning like what's the current weather in New York or Berlin or wherever, or what's the current price of Bitcoin or gold or whatever asset, or some data about bank payments, stuff like that, or like who won the latest World Cup in basketball, or I don't know, like connecting with TCP, different smart contracts on different blockchains, etc., etc. So you get a point. So the solution is basically, for smart contract connectivity problem, the solution technically is something called blockchain oracles. So now let's understand really quickly, if you don't know that already, what blockchain oracles are. So by definition, an oracle is any given entity that can provide off-chain data and computation. So, okay, what can be off-chain data and computation? Various data sources, external resources. We covered that, like, I don't know, let's say the temperature in Sao Paulo. Okay, but the thing is that there is a problem in this sentence, and that's any given entity. So any given entity can be a simple, I don't know, Express server you're hosting on your old computer, because by definition that technically is an oracle, because through an Oracle smart contract it can provide you somehow and somewhat data. So the thing is that now you have a completely decentralized infrastructure. You put all of your like backend logic on a blockchain. You have like completely decentralized front end and all of that stuff, and you're relying on a single node to act as an oracle, right? So my point is that centralized oracles are a point of failure. Basically, if your completely decentralized app relies on a single node to act as an oracle, you're at risk of getting inaccurate data or no data at all, right? So the solution to this problem, the oracle problem, is actually decentralized oracle networks, or DON for short. So decentralized oracle networks are basically networks of nodes that are not a blockchain, but still need to reach a consensus. So you want to connect any blockchain with any network or any off-chain data or any computation, whatever. But the thing is that those networks in a DON will need to reach a consensus. And we're going to talk about that a lot during this workshop, because if you want to get the price of, let's say, Ether, you're gonna basically ask Chainlink, like, hey, what's from your smart contract, hey, what's the current price of Ether in terms of USD? And all of these nodes in a DON can have its own source or sources for that price, right? So they can ping various DEXs, they can ping various, I don't know, taxes if they want, they can ping CoinGecko API endpoint, the free one, whatever, but they have various data sources. And then each node in a network will report its own price, right? And then the network itself will need to reach a consensus on the actual price and provide that price as a callback to a calling smart contract. That computation of price is done by using OCR2, which is short for off-chain reporting, which is essentially a peer-to-peer network where these nodes communicate between each other, saying, okay, my price is, I don't know, $50. I report 51 point something. Okay, I will gonna remember that, etc. So you get the point. So it's pretty simple mechanism. Okay, why I'm talking about like getting prices where we are doing workshops, when we are doing functions, during the workshop, I'll explain that to you in a couple of more slides. But the principle is the same. So you have some nodes in a network. They're incentivized to do the honest work with various mechanisms, and they need to reach a consensus on a final result. So you're now relying on a decentralized network on top of it, which can serve you as like a middleware layer between blockchains. So once again, Chainlink is a network is a decentralized Oracle network, but it's not a blockchain. So yeah, so the solution to the smart contract connectivity problem finally is Chainlink protocol, which consists of multiple services. So being data feeds, OCR feeds, proof of reserve feeds, NFT floor prices feeds, automation, CCIP, VRF, and finally Chainlink Functions. And today we're going to focus on Chainlink Functions. which is another service of Chainlink. So one thing to notice is that Chainlink is a blockchain agnostic, so you can use all of these services on whatever blockchain you want. So currently for functions which are like in beta, you can test them on Polygon Mumbai, on Ethereum Sepolia, and on Avalanche Fuji, if I'm not mistaken. We can check that on the official docs, but obviously more testnets and mainnets are coming pretty soon. Okay, so what is Chainlink Functions? So Chainlink Functions allows us to execute any code you want or we want to run and get the decentralized and verifiable consensus on the result using done. But what I mean by any code is literally any code. So uh, yeah, okay. So that code at the moment, the only language supported is vanilla JavaScript. But again, this is in beta. You'll see more and more languages added. You get the point. But that can be whatever you want, like literally any code. So imagine you have like you want to create some DeFi product on Solidity, and you on a blockchain. You know that Solidity is a bit hard when it comes to do some complex math. So the first thing that's a bit problematic, but not really, is the lack of decimal numbers. And what's more problematic is if you want to do some complex math, it will cost you a lot of gas. There are no natively supported operators, so you'll need to import a bunch of other smart contracts or libraries, etc., etc. But what you can do is that you can outsource that work for a fixed price to Chainlink Functions and just say, okay, I'm gonna send another request to Chainlink Functions. Chainlink Functions will do that computation in JavaScript for me. Okay, I know that vanilla JavaScript is maybe not the best language for a complex math, but you get the point. Like, you can do literally whatever you want, and like requests are always like fixed the same. So like it's literally a similar flow if you're familiar with VRF, like requesting the number values, all that. So all of that works exactly the same. Okay, so how these functions, or this function, sorry, works under the hood. So there are actually two steps that you need to perform. So the first one is you need to actually come up with the JavaScript file, which is the code which every single node in the John is gonna execute. So your smart contract is gonna ping Chainlink Functions, like send a specific request to the Chainlink Dawn decentralized Oracle network. And as I said, each node in a Dawn will run the same code, but in its own separate serverless environment and report the final result of that computation. So step number 2, the Dawn will then aggregates all of these independent computation results, applies a consensus, and once consensus has been reached, it will digitally sign the end result, so you can verify it cryptographically, completely off-chain or on-chain, however you want, and it's going to send the end result to your smart contract. Your smart contract only needs to know in which format you're going to send the response. Sorry. So you'll see that functions library can encode these JavaScript responses to all of basic data types, from units to strings to bytes to whatever you want. So that's not a problem. Just your smart contract will need to know to which data type to actually decode the response, because the response is in bytes. But I'll show you how to do that. So okay, so the always the major question is what my JavaScript code can be. And I said that multiple times. Your JavaScript code can be anything. So you can connect, as said on this slide, to you can connect your smart contract to some weather data, and then you can create some dynamic NFTs or some real-time sports results, dynamic NFTs, whatever. You could connect to password-protected IoT devices like your smartwatches, because you can also completely safely, in a completely decentralized manner, send the API keys if needed for your computation. any given secrets, etc. I'll show you how to do that as well. So you can connect to some external services like IPFS or Filecoin or some databases, get whatever you want for whatever data you want for, again, fixed price. Obviously, you can connect to any Web2 systems such as like AWS or Google Cloud or Twitter or Facebook, Firebase, Instagram, whatever. If you go to Smart Contract Kit GitHub organization, I'll make sure to share you that later. And if you search for all of these repos started with term functions dash something, these are all real world use cases of what you can build with functions. So you'll see the examples how to connect your dApp to like Twilio or Spotify endpoints. You'll see how to create like NFT giveaways using Facebook or Instagram pages to represent them as digital collectibles, how to connect to AWS to pull some data about prices, how to connect to ChatGPT, OpenAI with the OpenAI API key, and a bunch of other stuff. So functions are really powerful. It's just up to you to find the best use case for your dApp. Okay, if you still need more inspiration about that JavaScript code, you can go to usechainlinkfunctions.com website. So if you go to usechainlinkfunctions.com, you'll literally see like ready code snippets that are ready for you to consume, and you can just easily copy paste them into your project, and they are gonna work out of the box. If you want to add your example, just feel free to open a PR, and someone will review it. I will make sure to add it to this website. Finally, I don't have a slide for that, but there is from I think like a month ago or something, like pretty new. So you'll have the IDE for just creating that JavaScript code in the browser. So just find it or type it like Chainlink Functions or something, or using docs. So it's literally like an IDE where you can test completely online whether your logic is correct before you put them in your project or as that JavaScript code in your smart contract. Okay, and now we're gonna start with the actual workshop. I'm gonna share a different screen. Let's see, share screen. Okay, so I'm gonna quickly share the GitHub page. So this is the repo that we are gonna use. It's called Functions Hardhat Starter Kit. It's the official Functions Starter Kit written in Hardhat, but you can use whatever you want. I'm gonna use it because it has everything prepared for me, so I can test it easily. What I meant by go to Smart Contract Kit under organization here and search for functions dash something is that you can find a bunch of other examples. But before that, let's just git clone this repo. So I'm just gonna copy this thing, stop sharing my my screen one more time so I can go to terminal window, and then yeah, you should be able to see my desktop. So I'm gonna go just git clone this, and we can do Encode Workshop as a title. So this is gonna git clone into the Encode Workshop folder. So if we go Encode Workshop tab, alas, you can see that there is all of these files and folders from the repo. I see a question whether can I share the URL? Yes, I'm just gonna put it into the chat. So this is the link to the repo that we're gonna use. Okay, so what I'm gonna do now is that I'm gonna just open the Visual Studio Code. This is the code editor of my choice. You can do whatever you want, but I'm gonna type in Visual Studio Code. So this command actually opens the Visual Studio Code in a current folder. So I'm gonna stop sharing now my terminal. Sorry about this context switching, but I just don't want you to miss some important step or to assume anything. So one more time, share screen. okay, we need to go to window now. So Encode workshop, you should be able to see, yeah, here it is. Okay, I'm gonna close this. So first and foremost, I need to update my Visual Studio Code. I'm gonna open the terminal over here, embedded terminal here, and I'm just gonna type npm install, which will install this Hardhat project. And while we are waiting to do that, I'm gonna copy the URL for the functions playground, which is, as I said, the online IDE for just developing the JavaScript code. I'll have like some predefined code in the repo already, so I'm not going to use it. But yeah, feel free to use the playground. I'm using playground when developing new features all the time, so no worry about that. Okay, cool. This has been installed. Perfect. Let's do a quick tour on the repo so you can understand what we have here. So first and foremost, there is a contracts folder. So all of our smart contracts live here. We're gonna use this functions consumer as a reference. So I'm gonna just collapse this so you can see better. So you need to import functions and functions client libraries. Once this project is out of beta and you have like these contracts part of like official Chainlink contracts package, the import syntax will be this one. But for now, we're just gonna import it from local folders. So yeah, just be aware of that if you don't want to git clone the StarterKit repo. Then your smart contract just need to import the functions client like this, paste the Oracle address, use functions for functions request, and that's pretty much it. Apart from that, that's just regular Solidity. So this smart contract doesn't do a lot. It just sends the actual request to the Chainlink functions done, and then store the latest request info, like ID, latest response, and latest error if present in a storage variables. So you can see here that all of these responses are in bytes. So if you need to convert it to something else, that's why you need to know the underlying data type and Solidity so you can decode it easily. We're gonna go through that. Don't worry. So execute request is where we're gonna send the actual request to Chainlink functions. So source means the JavaScript code. Secrets, if we have any API keys or anything secret that we cannot expose as a plain text. So we're gonna put it here. I'm gonna explain you pretty shortly how we're gonna encode and decode those secrets. Arguments, if you have any arguments to your for your JavaScript code, you can put it here. Arguments that are like not mandatory needs to be secret. Subscription ID, so you will need to create a subscription ID, Chainlink function subscription ID. That's after you gets whitelisted. That's why I'm gonna skip it in the locals. But basically, subscription ID, which you can then gonna fund with link for executing a requests. So similar, not similar, the exact flow as you all already familiar and you already have in VRF and automation. And finally, gas limit. This is the gas that your fulfill request function can consume. And there is actually a hard cap on it, which is, if I'm not mistaken, 4 million. We can check that. So here you're just creating a request object. You're initializing requests. So you're saying, because at the moment on inline plain JavaScript, vanilla JavaScript is supported, you can hard code it like this, but you get the point. Once you have more languages, or you can get the code remotely hosted for, let's say, GitHub gist, instead of like passing it here to save some gas, you're going to change this to remote and this to, let's say, Python or Rust or whatever language, TypeScript, and this is the actual source code. So if you have any secrets, you're going to add it. If you have any arguments, you're going to add it like this. And finally, you're going to just send a request, and it will generate the function send request, returns the request ID, which is byte32 data, and we are just going to store it in a storage variable. But again, you don't need to, or if you need it, you can emit event or whatever. Finally, after done reach a consensus on a final result, execute your code in a isolated serverless environment. It will provide a callback, which it will do by calling the fulfill request. So one of the contracts that is connected to Chainlink Functions done will call the fulfill request function. So it will pass the request ID, this one. It will pass response and error, if any. And here we're just storing that in a storage variable and emit event. But you get the point. You need to just now do something with that response. Obviously, we're going to handle the errors with, I don't know, some require statement or something. And then you're just going to do whatever you want with the response. That's totally up to you. OK, cool. That will be the smart contract. So also this one, automated function consumer, is a more advanced one, which is connected to Chainlink automation. So you don't need to do anything, actually, apart from setting that up, of course. OK, so all of these tasks, tests, and scripts, and functions sandbox library, we can skip for now for this workshop. But these are just regular hardhead stuff, plus function sandbox library is a library which will allow us to locally simulate the execution of a JavaScript code in the DOM. Okay, here, this file is probably the most important one. This is a config file for functions. And you can see here that there are like a bunch of data types, and this is the actual config. So during this workshop, we're going to switch between two examples. But everything is going to be configured through this request config. So I'm going to just leave it here for now. And let's focus on two examples which we have here. So the first one is calculation example. The second one is API request example. So all of these are, as you can see, JavaScript code snippets, right? So this is pure vanilla JavaScript. And let's go through all of this. So first of all, calculation example. So this is an example which will show you how to calculate some amount of interest. So this is, let's say that you're creating some kind of DeFi vesting schedule contract or something like that. So you can do whatever you want basically. But okay, you're gonna send as an argument some amount, principal amount, some APY value, some percentage, do some calculation, switch that to scale that to years, and you can see here that we are doing the exponential function, and finally return the uint256 number. So you can see here that you can encode to uint256, encode to uint256, to string, or to a custom buffer. So custom buffer, it can be an address, it can be a complex struct, it can be whatever you want. So I'm more than happy to show you all of these techniques and to give you the URLs where you can see the actual code snippets. So this one is pretty straightforward, right? So nothing fancy there. So this is like the basic example. So how to run it? We need to go to config file now, and you can see that the location for code can be inline or remote. Currently inline is supported. Okay, so it can be like a vanilla JavaScript source code passed as a function argument or stored in a constant on a smart contract. In some future iterations, you'll see the remote option, meaning that you can, I don't know, like connect to a GitHub gist or some GitHub repo, whatever. So you can specify from where to get the source code. This is important, mostly if the source code is large. Currently, code language JavaScript, the only one supported, but we'll have more and more languages, pretty sure. So what you can return, so it can be uint256, int256, string, bytes, or buffer. Buffer is for complex solid data types, for arrays, for structs, and all of that stuff. Once again, I'm more than happy to show you how to properly decode them. Pretty simple. So this is the main object, request config object. So here you're going to specify the code location, the code language. We're not going to touch that. The third one is source. So where we're going to get the actual source code. So we're going to use the calculation example.js. So from the root folder over here, calculation.example.js. So this is our source, basically a JavaScript code that we want to be executed by nodes in the DOM. Okay, if we have any secrets, you're gonna uncomment this line and provide secrets. For now, we don't have it for this example, so we're not gonna use that. Per node secrets is not important for now. Private key. Okay, so for simulation purposes, and if you want to use this repo to create subscriptions, again, your wallet connected to this private key needs to be whitelisted to do that. But all that stuff, you will require to use private key from the environment. Coming back to that later. And these are arguments. So arguments that you're passing to your code, they need to be string. So you need to convert them in your JavaScript. But if you go back to calculation example, you can see here that principal amount is fifth element in arguments array, and APY times 100 is the next one. So if we go 0, 1, 2, 3, 4, okay, this is 4 and this is 5. So it's literally, so let's copy this thing. So principal amount is actually this number, okay, because it's coming from the arguments array from the config. Finally, what is our expected return type? If you go here, it's uint256. So you're gonna here specify the expected return type. If I do string, the end result will not be properly encoded. We can do string just to show you the difference. And yeah, that's pretty much it, right? So finally, what I want to show you is the usage of this package. That's env-enc npm package. So I'm gonna share you now the URL for it. It's present. It's present somewhere here. Yeah, here it is as a dependency. So I'm gonna go back to config so I can share to you the Chainlink env-enc npm. Here it is. Okay, here it is. Just give me 20 seconds to find it. Chainlink env-enc. Here it is. Copy, put it into the chat. So this is the package that we're gonna use, and I'm gonna explain to you now why. So you know that when you're working with your, I don't know, your smart contract projects, oftentimes you need to deploy them or interact with them on chain or something. So you're gonna go to hardhat config, Here you're going to specify, hey, my private key is coming from env file, which has private key variable, blah, blah, blah. The thing is that if you're probably going to do something like this, .env, and then you'll have private key, and then your actual key, blah, blah. Okay. Thing is that you need to be sure that .env file is present into git ignore, like here, and it will yell at you, don't push the environment variables to GitHub repo and all of that stuff. But unfortunately, it happened in the past that devs will, by accident, push the private keys to repos, and because of a bunch of bots monitoring the GitHub, they'll just get, their wallet accounts will just get compromised, right? So to save you trouble from that, the env-enc package is gonna encrypt your variables, your private variables actually, into this file .env.enc. I'm going to show you how, let me just show you. The thing is that it will not, your secrets will not be present in a plain text, although it's not a great idea to push them to GitHub anyways. If pushed, it will still be encoded, and only you can decode it using password, right? So let's zoom this a bit so we can see it better. I'm gonna collapse this. We're just gonna focus now on the terminal. Okay, so there should be a README for this repo, by the way. Here it is. Let's preview it. Preview README. Okay, here. So I'm just gonna focus now on setting up. Here it is, on setting up the env variables. Okay, terminal. Here it is. So first and foremost, when you're using env-enc, you're gonna do npx env-enc, and you're gonna set some password, right? So you can do whatever you want. It will be, you can see here, the input will be hidden, so you can do whatever your password is, right? And hit enter. That's it. Now we're gonna use npx env-enc set command to actually set some variable info. So for this workshop, I'm gonna need to set the private key. So this is the name of the variable. Why? Because if I go to request here config, you can see that process.env is the name of the variable, is actually private key. So private key, I'm gonna hit enter, and now I'm gonna enter the actual private key. Okay, so I'm gonna copy from your wallet, whatever, hit enter. Would you like to set another variable, or you want to finish? If I hit enter, I'm gonna finish. If I want to set another variable, I'm gonna just set another variable, and I need the Polygon Mumbai RPC URL, and I'm gonna just paste my Polygon Mumbai RPC URL. Hit enter. Do you want to add another variable? I don't, so I'm gonna just hit enter to finish. And that's it. So now you can see here, just zoom out a bit, you can see here that the new .env.enc file has been generated. And if I go here, collapse this, you can see that there is a private key, there is a Polygon Mumbai RPC URL, but this is all base 64 encrypted. So even if I push this to the repo, you cannot steal my funds, right? So if you want to make sure that you enter the values correctly, you can do npx env-enc view command, and when I hit enter, you can see here that this is the data I have inputted. So for private key, I typed dummy private key. For Polygon Mumbai RPCR, I just smashed my keyboard. So you can now see that this dummy private key is not the same as this VHFA S capital YY, whatever. So this is encrypted, this is encrypted, right? Okay, but for example number 2, API request example, I can see that I need an API key here. So I need an API key for CoinMarketCap or CoinGecko, blah, blah, but I forgot it to add it. Well, that's not an issue. So npx env enc set, and you can just set another variable, which can be, what's the name of it? Sorry about that. Config. Here it is, CoinMarketCap API key. So I need, for example, that API key, blah, blah, enter, finish. Let's go to env.enc. You can see here I have another variable on top of these two ones. And when I tap view, you can see that I typed something more. So this is what's mandatory for extra security. So you're gonna need to use this package, because we need to send secrets to the dawn. And the thing is that we need to create a mechanism where nodes can decrypt the secrets using their public keys, but also we need to create a mechanism where multiple nodes will be required to decrypt a single variable in case some node is compromised, right? So to prevent central point of failure there. Okay, so finally, what I'm gonna do, because I have a bunch of dummy variables over there, I'm just gonna copy the actual env that I need. So I'm just gonna repeat with this, save, and that's it. Okay, we don't need this file anymore. Let's now go back to our calculations example. So we're going to use a calculation example. We're going to pass these two numbers to it, and we're going to expect uint256 to come as a result from this simple math. So how to do that? So you can test all of this locally by typing npx hard hat functions simulate, right? So now it will first compile my contracts because I forgot to compile them. And after compilation is finished, here it is, successfully, it will execute the JavaScript source code locally. So this is a local environment. Nothing is on chain. As I said, if you want to test this on testnet, mainnet, whatever, you'll need to fill up a simple type form. But for development purposes, you can do it here locally. And this is the output from the source code. This is the actual value. So you can see this is this number in a hex representation. And this line encode to uint256 converted to the uint256 value, which then we returned to calling smart contract over here. So decoded from uint256. So this is the actual result. And you can see here that for sending a request, this is the gas usage. So this is transaction number 1 to send the request, the execute request function. And the fulfill request functions, the second one called by dawn, which stored the actual response and errors to storage variable, will cost actually approximate this amount of gas. So what I'm going to do now is that, so you can see here that I'm encoded as uint. So I'm going to go to config and on purpose, switch this to string. So you can see that you need to be careful with that. Clear, and I'm going to repeat the process. So function simulate. And you can see here that now we have some bytes value p, some unknown character, right? So our smart contract expected string, but we encoded it as uint, sent out those bytes, and when our smart contract tried to decode it to string, it got this value. So you need to be not careful, but aware that it's important to properly encode and decode these values because all of them are bytes. That will be for this simple example. Obviously, the more complex one is when you want to call the to use some API calls, HTTP GET, POST, PUT methods, whatever. So this example is basically how to get some prices using Chainlink functions. So in reality, you're going to use price fits. But this is just to show you how you can do the same thing using functions. Most importantly, this is to show to you how you can create HTTP GET, HTTP POST request using Chainlink functions. So there is no vanilla JavaScript code, meaning that there is no like npm installed for these JavaScript files for now. So you cannot like npm install Axios and call to make an HTTP GET request, but this functionality is actually embedded in functions library. So this is just to get some API keys from arguments. And once again, that comes from the config file from this. So this is the idea. So we want to get the price of Bitcoin, basically. From what I need to do is I need to switch the source from calculation example to API request example. Now this JavaScript code we are going to use for simulating a response, and we also need API keys, more precisely CoinMarketCap API key for secrets, right? So what we're going to do, if there is no API keys, well, you need to go here to get one. Okay, this is like a free API key, pretty simple. But what I want to show here is this is a syntax to get the arguments, to get the argument from the arguments array, which needs to be a string. This is a syntax to get the API keys. So secrets.api key. So because here is .api key, I can do y, and now I need to change it here because this is going to be undefined. This will actually get the API key. So don't confuse this object property with the variable in .env file. So these can easily be the same name, but again, you cannot do here secrets.coin market cap, whatever. It will not understand what you mean. So you need to do API key because here it's API key. Okay, so you're getting that from the secrets object. Okay, then we need to create an HTTP request. So to create an HTTP request, this is the syntax. So from functions library, there is a function called make HTTP request. So you need to provide URL and optionally some other parameters. If you don't provide method, it will be default the get. So if you want to do a post request, you will need to do something like this. So method post. Okay. So this is your URL. If you have some headers, params, data, timeout, response type, all that you can paste here. So this is literally like Web2 coding when you're querying some API endpoint. So this is for CoinMarketCap, this is for CoinGecko, this is for CoinPaprika, and this is some bad API request. So now this code will basically await for all of these responses to come back. And if there is any error, it will just console log errors. And finally, it will push all of these responses to a prices array here. And then it will just, if there is a failure, it will report that, and it will just find the median price of all of these prices. So it will go through, this is a JavaScript syntax, it will go through a JavaScript array, sort it, and then it will do a simple math calculation, which it will divide the length to 2 and round it up. And finally, it will just scale it to 2 decimal places. And it will send it back as a uint256 value to a calling smart contract times 100. That means that your calling smart contract will need to take care that this price will come with 2 decimal places, so it will need to do some proper calculations as well. And that's pretty much it. So this is a code from the request config. We just need to add CoinMarketCat API key. All of this, the rest of the config is the same. So if you want to try to do it with me now, we can go to coinmarketcap.com/API. Here I'm just gonna paste it in my browser, get our API key now, and I'm gonna copy it. I'm not sharing that, sorry. So really quickly. So you will need to go to this URL, okay? And just, if you haven't already, sign up for the key. What I need to do now is that I need to set it. So clear, it should be npx env enc set, and request config is coin market cap API underscore key. Paste it, enter, and do npx hardhat functions dash simulate, hit enter, and if everything is well all right, it will switch to a different JavaScript code now. It will calculate that the median price is $27,200 something for a single Bitcoin. It will encode it to a uint256, and it will send it back to my calling smart contract. So it's literally a solidity number, and I need to make sure that the number of decimal is 2. So I'm gonna use this value properly. See, there is no decimal places in solidity. And finally, once again, gas usage for both transactions. That'll be it. We have less than 7 minutes left, so I would like to leave that time for any questions if needed.
Amazing. Thank you so much, Andrej. That was a great session.
Thank you. Appreciate it.
Okay, so let's just have a quick look at the questions. I believe we have a couple of minutes to address those. Okay. So the first one we had is, why don't we just go top to bottom for now?
Okay.
Shibam asks, will the functions be helpful in connecting to Internet of Things or devices like scanners, etc., through API, RPC, ...
Yes. So definitely, if that IoT device or whatever, like scanner, whatever you want to connect to, has like exposed API which you can connect to using API key probably or not, then definitely you can use Chainlink Functions to connect to it in the same way I connected to CoinMarketCat API key. But you get a point, like you can connect to your IoT, I don't know, like to your scanner or smartwatch, or I don't know, like PlayStation if possible. I don't know what else. But yes, you can do that as long as they have like an public API that you can connect to. That's it. Get, post request, whatever. That's totally up to you. And then with that response from IoT device, it's again totally up to you what you can do it and how you want to connect it to a blockchain, your smart contract. But yes, it's definitely possible.
Okay, amazing. I guess the next question then, I'll go down to Adegbenga, who asks, is it possible to write functions in Solidity?
Not yet. So at the moment, the only possibility is vanilla JavaScript.
Cool. James asks if you can explain parametric insurance.
Parametric insurance. Yes, actually, there is a blog post. So if you go to blog.thechain.link, I think, no, I'm not think, I'm absolutely sure that it's live now. So there is another use case just for parametric insurance. I don't know what the actual API keys, what the actual API endpoints they're using, because I haven't wrote that article, but I'll make sure to find it out and post it here. But yeah, it used Chainlink Functions, and that example is actually nice because it off-chainly encodes the functions requests and store them as immutable or constants to save some gas. So I definitely recommend it to check it out.
All right. Well, if there's any resource that can be sent out there from after this workshop,
sure.
Don't worry about it now, but just
Okay.
for everyone here, I'll be in touch afterwards with any relevant resources from today's session.
Okay, cool.
Cool. Okay. Finally, we have Satish, who asks, can we use JavaScript or jQuery plugins and libraries in these functions?
So jQuery, not yet. So the thing is that it needs to be vanilla JavaScript only for now. So anything that is not vanilla JavaScript cannot be used at the moment. Sorry. So yeah.
All right, cool. Well, okay, we have one question that's also come in
Okay.
now. What if we made a request to get weather info and the request is sent by 4 nodes? So if in case every node gets different result, what is the final result?
That's an actual question, actually. So basically, yeah, if you have, and that's the real possibility, right? With external data for sure. So if you have 4 nodes, all of these nodes will report the result it got. So if weather info changed, let's say that 3 nodes report that the current temperature is, I don't know, 20 degrees Celsius, and the other one reported 21. So three votes for 20 and 1 vote for 21. That's a consensus that the end result and the actual weather temperature is 20 degrees Celsius, and the John will report 20 as a result. But if you have a situation where all 4 nodes reported different values, or situation is like 2 to 2, like 2 20s and 2 21s, that means we don't have a consensus, and it will actually, response will be an error, like there is no consensus on this request.
All right, cool. Well, I think I see Shabam typing, so if he has any follow-ups, I'll let him do that now. But in the meantime, I think we are getting to the end of the session. I understand that some of you will probably need to leave. But just as we're closing off, and this is the last Chainlink Bootcamp session, there were a couple of things that I wanted to bring up. So if you have a little bit of extra time, stay behind for 2-3 minutes for some exciting opportunities. All right, let me just share my screen. Does that look good for end, Andrej?
Yeah, looks good. I can see it at least.
Okay. Amazing. So long story short, if you've enjoyed this program, we also have some incredibly exciting programs to join here at Encode that are coming up. As some of you know, we've just launched a couple of new programs for Q4. So here's everything you need to know if you want to keep learning and keep doing more stuff in Web3. So the first thing that's very exciting is that we're currently running an open data hack. Chainlink is actually offering a bounty on this hack, so we do want to shout them out and make sure that if you want to apply any of the skills you learned during this bootcamp, you go and do so there. The submission date is incredibly soon. It is September 27th. But if you're really keen to hack and apply your learning, scan this QR code and you can get more information. All right, so another exciting hack we have at the same time is digital identity hack. That is with our partners Onyx by JP Morgan. The submission date is October 8th. It's only recently kind of got started. And again, if you want to keep learning about that, there's a very strong identity focus in this hack. So if you're interested in that, want to learn more, make sure you go check out this hackathon. And to close off, we have some very fun Q4 bootcamps coming up. So amongst these, we have the AI Foundation Bootcamp. This is the first time we're running a bootcamp related to AI. So if you want to dive into that, great opportunity. And then you can also see some of our classic bootcamps being run again with new cohorts. So if you want to touch up on some learning or dive into a new Web3 language, this is your chance to do so. Otherwise, I wanted to give a big shout out to you all for being such active participants in our bootcamps. It's really been great to see you all engaged during this this bootcamp. I love the questions that you brought to every session. You've been fantastic. So give yourselves a pat on the back for all the learning that you've done thus far. I guess with that, that's the end of the Chainlink Bootcamp. It's been great getting to know you all. Big thank you again to Andrej for his session today. And yeah, I'll send out any relevant materials as always in the Discord channel and maybe even over email. With that, cheers everybody. Bye.
Thank you. Bye.